Remember, PLC stands for Programmable Logic Controller. And here we need to discuss why PLCs. And please subscribe to this series of PLC training. It's an investment in your future. It's an investment in your skills. And it is vital that you follow these training sessions in sequence. And I hope you learn something about it. And I hope you will get confident with a PLC. To a lot of people, a lot of artisans, PLC equipment is still a strange type of equipment, and they don't feel confident when dealing with PLC equipment. And please note that these series of training lessons is designed to give you that confidence by taking it step by step every day. Do not try to be a PLC expert tomorrow, but try to just get through the training videos step by step. And at the end of this series, you should be confident with PLC equipment to do the proper fault finding and to understand a little bit of the world that we have in the industry. Now, the one thing that we need to discuss, why PLC? The modification is effective if needed. To understand this point, one needs to think about the challenges the automotive industry faced during 1968. New car models were required on automatic assembly lines. Huge panel with relay logics was mainly used for the control systems. Some of these panels had to be modified for the newer models. This resulted in downtime and other maintenance issues such as incorrect wiring, and even further downtimes were experienced. To rewire a control panel for a new requirement is not a joke. I think we all went through this process where we design a panel and we think it's perfect. Just by the next day or the next week, a new request will be made and say, we now need to add a conveyor to this machine. And then this complicated the whole matter. And while we're during this modification and adds on to this panel, then we will find out that during previous fault finding challenges, some cable markings could have been lost and some modifications were sometimes made by artisans in the attempt to keep the plant going. Now this resulted in extra and unforeseen challenges. I always call this the surprises, and I hate surprises. When you try to modify an existing panel, you will sometimes find out that the wiring is incorrect. The sketch that you got is not relevant to what is being installed. Now today we have a system as shown below, and I will show it in the next couple of seconds. All inputs and outputs are wired to a PLC separately. Now the benefit is, if modification is needed, the software program of the PLC will be modified. With the technology of today, different programs can be used for the same inputs and outputs. If more inputs or outputs must be added to an existing system, then the new inputs and outputs can be added quickly to the existing PLC. If the modification is of a major concern, even an additional panel can be added with all of the new inputs and outputs to the existing PLC with ease. Now, today, the most used PLC programming tool is ladder. Now, ladder represents no challenge to an electrician. It's equivalent to an electrical drawing. Now, let's look at this display. Now all the inputs in a field, and this is just a concept drawing, it's not the actual wiring, because in the actual wiring all the inputs in a field will be connected separately to a PLC, and the same with the outputs going down to the outputs. Now you will remember that inputs, when we use a button, for example, with a PLC, we will supply the one end of the button with 24 volt and the other point of the button, the other switching point, will be taken to the PLC. And that's why the arrow is clearly showing it from the inputs to the PLC. The PLC inside has got a software program that looks at the logical. If this and that or this is at a high level, then the output must be switched. And that switch outputs in a field such as contactors. Now, also note the direction of the arrows. Inputs represent items such as switches, buttons, binary switches, auxiliary contacts. With other words, all items that can be used as an input to the PLC. We call those items digital inputs, as it can have only two states. Namely, it can be on or it can be off. The signal can be high or low. But when we talk about inputs, we can also have analog inputs, and this represents variables such as voltage, current, pressure, etc. You will notice that outputs are drawn with an arrow away from the PLC. That represents an action that will follow. Now, PLC will energize contactors that will start motors, switch on lights, switch on hydraulic valves, and this type of outputs are called digital outputs. And they can also be on or off. And that's why it's called a digital output. Now we can also find analog outputs, such as a variable voltage of 5 volt to a hydraulic servo valve to position a hydraulic cylinder correctly. And analog is also items that we will come across during this training session. And the analog is not a digital signal. It's not on or off. It is between those two limits. It could be 1 volt, could be 1.2 volt, could be 3 volt, 4 volt. In other words, it's variable. And there we talk about analog inputs and outputs. Now the next one that is important, why PLCs? Now bypassing of circuits can be detected. Now, some artisans do resort to the breaching of certain components and inputs to keep the plant in operation. Now, this results in challenges later, and fault finding do become difficult when one realizes that the sketches or the drawing of the machine do not reflect the actual wiring on the plant. With a PLC, it's easy to monitor certain key elements, such as switches. Now, switches normally will allow a signal to the PLC for a certain time period. The operator will press the button and release it, for example, to start the machine. In the program, we can have a watchdog on the button. If the button is pressed for an excessive long period or the switch is breached, then the program will flag a warning or alarm condition. Here we can even use rising edge and falling edge. And we will discuss the difference between a rising edge and a falling edge in more details later. What is important to understand is a rising edge means that the signal was off and it was switched on. At that moment when the voltage goes up and the PLC input is recognizing that signal, the software program will then start to do certain routines as programmed. We can also make use of a normal input with a timer. If the input is on for a certain time, then the timer will time out and make an alarm. Now, the use of PLC make it difficult to bypass or to short circuit the inputs. Now, outputs will only be switched on when the correct input conditions are obtained safely. If one uses a watchdog timer, for example, with the PLC, breaching of inputs can be detected. Every input and every output will be connected to its own terminal at the PLC. Now the drawings, if you do this, the drawings will stay relevant and will ensure that fault-finding techniques are applied and that shorter downtime experience. Today, point 3, data recording of certain key parameters is easy with a PLC. And today the questions has always been asked, at what speed is the conveyor running? What was the output yesterday? What was the output today? With normal conventional relay logics, the what we call the clickety-clack panel, it is not possible. But with PLCs, we can record data for fault finding, investigations, or testing easily if we use a PLC. With logic relays, data recorders, and counters, it is very difficult to do with hardwiring panels. For example, with a PLC, we can measure the capability of a machine very easily with the use of CPK for a machine. For example, if we talk about a machine that is cutting pipes into a certain length, we can use CPK to determine the capability of that machine to cut that pipe inside its maximum and minimum tolerances. And we can predict how good the machine can do that cut. Now soon somebody will ask the question and say, okay, you have made all of these changes to the machine and we got a PLC on, but the question is, how capable and consistent is this machine in terms of statistical capability? And the measurement is CPK. We can actually program the PLC to calculate CPK for a machine. In the automotive industry, a CPK of 1.33 is the minimum acceptable capability of a machine. And you can read more about it on the internet and how it's being used, or you can contact me and I'll give you a little bit more description of CPK. Man-machine interface. Today we live in a world where people change job positions often. A short learning phase and a short learning cycle must be in place for any new employee. If we connect a display to the PLC, we can assist employees with help functions, machine settings, and written instructions on how to operate the machine safely. For the maintenance personnel, on the other hand, we can write help pages to assist in the fault finding. In most cases, you will find a faulty input when the program malfunctions or when the machine halts. Now, the use of man-machine interface accelerates the fault-finding techniques considerably, and standard machine settings for the operator can be added to the machine as a baseline reference. And we are getting, in today's world, it is much more easier to interface the man to the machine, where both of them can have a communication in helping each other. Now, in the industry, we'll find that some maintenance departments are fitted with supervisory PLCs that will alert the maintenance department before even assistance is called for this machine. Now, even alarms can be added to the human-machine interface that will lock any dangerous or incorrect operation of the machine, or they can alert the operator of any dangerous setting or condition. With this in place, the safety of the plant personnel benefit greatly. With hardwiring and relay logics, this is not possible. But with the PLC, a competitive advantage can be gained above the competitor. Now, machine data such as production output can be measured, and the machine can alert the supervisors if the targets are not met. And it's also possible to predict that the shift target will be met or will not be met. Because the PLC is a real-time instrument, it actually measures the output at this point, and it can calculate for the shift that is 6 hours later, for example, what the final output will be based on the conditions as current. Now, this data can even be sent to a cell phone via SMS message or as an email to the manager in charge. And you don't have to get to the end of the shift before you realize that there's a serious challenge, because then it's too late. For example, an end of shift report can be generated automatically, and this report is objectively. The PLC will not tweak the figures, it will actually give you the real objective data. Now again, with hard wiring and relay geologics, this is not possible. And point 6, with the aid of a PLC, we can even apply predictive maintenance techniques. Now, any plant do have conventional maintenance systems in place. With the application of a PLC, one can apply more advanced predictive maintenance techniques. For example, with the aid of a simple temperature readings on bearings, one will be able to predict that the bearing has a potential failure when this bearing temperature started to increase. And this happens before the bearing fails. So you will become aware of a challenge, a maintenance challenge, before it actually halts the machine. It can also flag requests for certain maintenance items such as the greasing of the bearings. All bearings have a certain time interval that is required then to do lubrication of that bearing. For example, a certain bearing can have a runtime of 2,000 hours and then it will need lubrication. But this is very effective when a PLC starts to monitor the actual runtime of the machine. We can even do a software program where it will monitor the loading of the machine and the runtime of the machine. And based on these two parameters, we can then predict at what time it will be needed to lubricate that machine again. And there's various examples of this. For example, I've just added cooling of panels. Now, cooling of panels can be verified effectively. The way we do it is that we use a differential pressure switch which is fitted across the filter. With other words, the one end will measure inside the panel the pressure, and the other point will be outside of the panel, and it will measure the differential pressure between inside and outside. If the filter blocks, the pressure on the inside will actually start to drop, and it will give you an alarm that the filter needs to be replaced. Now, one can use the loading of the machine and the actual runtime to predict certain maintenance items that must be done. And the beauty of a PLC is if the operator or the maintenance personnel ignore the warnings of this PLC, we can even halt the machine, especially when the machine safety or the people operating the machine is in danger. Now, with relay logics, this will result in one massive panel with unreliability. Now, point 7, machines can communicate with each other. With networks that interlink the different PLCs, we can share data between PLCs. For example, a classical one is if we have 3 conveyors and 3 PLCs controlling the conveyors, the one conveyor can inform the other one that the product output is getting less, and they will all be able to reduce their speed without complicating the production process. Now, upstream equipment will not be able to function if, for example, the downstream equipment is not operational. This is more for cascading, where you have, for example, a conveyor must be started only when the upstream conveyor is started, or else you will create havoc. So the machine can start in sequence and in proper sequence. Now this results in a safer machine usage and energy savings. The equipment only runs when needed to run. Even today, the operator can send a message on his screen, on his human-machine interface, to the operator of another machine. Now, interaction between operators can be done easily and effective with these methods. No need to walk to the operator that is 50 meters away from him. He can just use the HMI to actually flag a message to the other operator. Now, supervisory computers can easily collect the data from individual machines for a complete line report about the performance of individual machines and operator performance. And it can even give you your total plant performance. Point 8, why is PLC so important? Now, with PLC equipment, it's easy to generate electrical savings. Electrical operational cost is significant in the production operating costs, and it can negatively affect the profitability of a company. For example, one of the simple control systems, a cooling tower fan, speeds can be varied to the exact minimum fan speed. What we mean by this is that if I got a cooling tower that only needs to be cooled down to 25 degrees as a cooling media to filters in hydraulic systems, we can actually vary the speed as needed. If the ambient temperature is only 12 degrees, we will actually halt the fan with the drive, or we will reduce the speed to such an extent that the temperature in the cooling tower is maintained at the required 25 degrees Celsius. With normal conventional system and relay logics, normally the fan will just run all the time and will cool the water right down to the ambient temperature, and that's a loss of energy. Only use energy when you need it, and then use the minimum energy is a principle of engineering. Now, certain machine speeds can even be reduced when a reduction of products is achieved. With other words, if the products on the line is reducing, for example, conveyor systems, you can reduce the speed of the conveyor system to match the products that is being dumped onto the conveyor belt. Okay, here we can think of a conveyor that receives finished goods and is transporting these goods to the warehouse. With conventional relay logics, you will operate the conveyor at full speed for all relevant operating conditions. With PLC equipment, the control systems effectively measures the speed of the conveyor belt, and if a reduction of goods dumped on the belt is experienced, the conveyor speed can easily be reduced to match the delivery of the goods on the conveyor. With other words, less product on the belt, the slower the speed of the belt. Now, certain machines that is idling for an extensive period of time can be switched off automatically and in safe mode. And this is a huge field. This is a total different aspect of engineering, but PLCs play a major role in energy saving. On point 9, we will discuss quicker fault finding. Now, if illegal bypassing of control components can be minimized, machine schematic drawings are maintained as designed, then fault finding is very quick and easy. The maintenance manager can be assured that illegal connections and modifications are not made. Now, this ensures effective fault finding and safe operation as the machine was designed from day one. Now, with relay logics, this remains a challenge, and I found strange modifications in my lifetime that did not add any value. And the problem is, I always state, never ever modify a machine unless it is in a controlled environment where the sketches is updated, all the information is showing the new alterations or modifications to that machine. But this private bridging of circuits and own designs are creating a challenge in the future. Now, calibration of external analog devices such as temperature probes, scales, and instruments can be done effectively. Now, today we have a lot of people that is not skilled or still lack the experience because they just became an artisan. And this is the people that sometimes make a mistake, not deliberately, but due to the lack of knowledge. But with the assistance of a human-machine interface today, calibrations can be simplified, even when the machines are maintained by artisans with a lack of knowledge. The screen can be used effectively to calibrate the probes and other instruments safely, which is not possible with hardwired panels. On the man-machine interfaces, we can add logical steps for the artisan to follow. Step 1, and we can actually explain the procedure of the calibration to him, and we can support this even with a help file for that screen where he can refer to it if he gets stuck with calibration. Now, PLC equipment is much more compact. Now, today, the PLC equipment is much more compact and it contains a smaller space than 50 years ago. Today, we will also find PLCs inside drives, AC drives. It is no more longer needed for a PLC and a drive to be a separate component, but a drive that can communicate to a different drive via a network. Even temperature thermocouples can be interfaced directly to the drive without even purchasing a different PLC to fulfill their duties. Now, this do make the panel even more smaller. On the market, one can even find HMI and PLC as a combination, as one unit, which makes wiring and interfacing much more easier. And below, I'm showing you the Delta PLC. This is a SE PLC. It's a SAL PLC, a network PLC. You can see there's an Ethernet connection right under the top. And the photo doesn't reflect the actual size of this PLC, but it's very small. It actually fits into your hand. What is interesting here is that we have 4 outputs and 8 inputs that fit in your hand. So we can actually have, this can fulfill the role of 4 auxiliary relays. And interesting to note that if you look at the Modicon, and you can do this as an exercise, type in the word Modicon 84 and you will actually be able to see photos of the original Modicon. Now, this little unit is powerful. It is actually cost effective. If you look at the cost of this unit and you refer it back to the original price of a Modicon 84, it is a shocker. Now, interesting enough, here the standard interfacing is also 2 RS485 networks, and you got your Ethernet connection down there, and here at the bottom you will see your 2 RS485 networks. Now, the actual size, just to give you an idea, the unit is only 9 millimeters high. From here to there is 90 millimeters high. Across from there to there is about 37.4 millimeters wide, and the depth, that part there, is only 60 millimeters. So it's very, very tiny, but at the same time, it's very powerful. Now, you can expand that unit, you will see, and we will talk about this later. On the left-hand side, you can add special blocks in here, and you can use these clips to insert another module. And for example, we can insert the scale unit onto this side here, and this is the fast processing side. On the other side, and you cannot see it, exactly the same connection can be seen. And we can actually extend this unit up to about 480 input and output points, which is quite large. And you will very rarely need 480 points of input and outputs. Now you can actually fit on this block, you can fit analog temperature probe blocks, and even scale units can be connected as needed. Now the price today, there is no excuse not to use a PLC. The price is very reasonable, and even homeowners are nowadays using PLCs. Now the one thing that we need to discuss, the benefits of PLCs, is the longer lifespan in terms of relay logics. Now PLC equipment today is very reliable and offers a longer lifespan of the equipment. PLC can consistently do the same thing over and over without any failures. PLCs is reliable, and with the correct application and design, it can even outlast the life of the machine. Also, what is important today, that we have very fast switching applications, and we're using a lot of SSRs nowadays in the industry, for example, to control temperature zones. SSRs, we will discuss this at a later stage in the next video. But the problem is with the SSR, especially when you do pulse width modulation, the SSR do get switched on rapidly. And with normal relay logics, that relays is not able to switch fast on and off, the same as an SSR. Now PLCs, they are much more accurate. If we do batching of raw materials, for example, with a scale, the control system will do the batch measuring very accurately, and it can do corrections to the next batches if discrepancies are experienced. Now this can create huge savings in raw material costs. I have done a project on 400-ton silos, for example, where the loss of raw materials in the previous years exceeded 6 million rand, which is a huge benefit, and the cost of such, you cannot even compare the cost of a PLC equipment against the loss of raw materials of 6 million rand. Also, 14, what is important, that PLC can do soft starts on the machine. With normal relay logic panels, it's difficult to control the startup speed of motors. In the old days, we actually use more DC motors with huge liquid starters and oversized equipment. And the use of DC motors brought its own challenges. Later, we have introduced inductors in line and startup of inductors, but it's not really practical, and it does take up a lot of space. Now, with an available reference to a drive fitted to the motor from the PLC, one can actually soft start the drive during startup. With other words, we can give it a speed reference, and it will start slowly and then start to accelerate or decelerate as needed. Today, even your drive does have accelerations and decelerations, speeds built into the circuit. And your PLC can interface very easily with these two, and they actually complement each other. Now, if you do a soft startup of a machine, it will naturally tell you that you will increase the life of motors, your bearings, your gearboxes, your shafts, your gears itself, and your pulleys and your V-belts. Because the machine is not shock loaded at the moment. It's not trying to accelerate from 0 to 100% all the time. It is actually accelerating in a controlled fashion without creating shock loads to your bearings and to your gearboxes and motors. And it's naturally that your components will last forever. And if you actually connect this with speed reduction, your life will also be extended. And it is one of the benefits of a PLC that cannot be ignored. Now, a reduction of failures of the engineering components will cause a reduction of the maintenance budget. Now, 15, it forces the artisan or the person working with the PLC to develop his logic thinking pattern, and it allows him to think out of the box. I always say that if you can dream it and you can write it down on a piece of paper what you want to do with a machine, then a PLC will be able to do it. And a PLC is all about logic and reasoning. It's all about if this and this, or this and this, and this and this is at a level that it is high, then the output will follow. So you are forced to actually think in logic terms, in terms of ands, ors, and nors, to actually understand what the PLC program is about. Now, on the other hand, if one stares at a huge relay logic panel, it is sometimes difficult to comprehend what this panel is really doing. And what complicates this matter, in cases of huge control logic panels, you will find a massive book, a massive file on this machine. And to actually get to the right point where you can do a fault finding is very, very difficult. Now, for example, today we use a SFC tool. It's easy to understand how the machine is functional and is actually functioning by just looking at the SFC program. Because your SFC stands for Sequential Function Chart. Now, this chart inside the PLC actually represents the program is the equivalent machine flow diagram. And this is highly, highly helpful. Because even if you never work with the machine, if there's SFC being used inside the PLC, you can actually understand what the machine is doing at certain times. And in our lives, this is very important, because if you get to a machine that is not operational, to understand how the machine is working is very, very difficult. I always say during my training sessions that the most important tool that you can have is to understand how the machine is operating. You can, even if you don't have PLC equipment, you can use the SFC concepts to draft the operation of the machine to assist in fault finding. And in my life, I have met people that refuses to use any laptop to help them with a fault finding. In their minds, they got an SFC diagram actually drafted, and they know exactly what will happen if that input is made and that input is made, then this will happen, and they understand the machine. And even without the aid of a laptop programmer, they can actually find a fault on the machine. Now, it's easy with SFC to determine the relevant function, and it's highly recommended to always follow this programming technique as much as possible. With ladder logics, this is not difficult. With ladder logics, it's very difficult. And you have to have a system in place that will describe to you the different functions of the machine. And for you to discover the functions is really, really difficult. Now we get to 16. Some of the programming developments can be reused. In today, speed and turnaround time is very, very important. Today, PLC development must be done at speed. With the use of a software program called a function block, some codes can be reused. For example, let us say that you use a star delta program for starting an electrical motor. It is very difficult to do this program and to actually program it inside the PLC every time when you need it. But what you can do is you only need to develop a proper function block with the time settings, the enabling of the star delta, etc., etc. You can then design a function block, and you can reuse this function block with the next program without redeveloping this program. You can just take the function block, drop it in the program, and actually connect it as required. And we will get to function blocks at a later stage. And it's a very, very important, powerful tool that you must be able to use. Because the use of the function block is actually a sum up of a lot of programming inside the block. And it gives you like a top approach where you can see that this is the inputs and that's the inputs, and if I get those inputs, then the output will be there. Now you can design, for example, a function block for a PID. We will discuss PID at a later stage, and we can reuse. If I need another PID programming to be done with another program, I can just call the PID function block. I can insert it in my program, and I can give it the relevant inputs and outputs as needed. Now, the use of function blocks is recommended as it simplifies the development of the program in the future. Now, if you later start to use Siemens PLCs, then the term function block must not be an obstacle to you. Then you already met this in Delta, you have experienced it, and you should be able then to understand function blocks in Siemens PLC. In today's language and in today's use of PLCs, there's a common standard that applies to all PLCs. So if you learn the one PLC and you became a master of a PLC that you can do analogs, you can do networks, you understand the addressing, you can actually apply this learning that you have done with the Delta PLCs on any other PLC. What is also very important, remote monitoring and developments can be done. With hardwiring logics, all the artisans must be on site. They must be wiring the panel. It's always a challenge because only one person can get into the panel. So there's a lot of delays when you do hardwiring control panel. But today, with our technology that we have, programming can be done off-site and can be simulated for correct operations before you even install it on a plant. And this is not possible with relay logic. Now, what is very important to note here as well is when it comes to PLCs, if we have a machine that is operational and it's in production, we can actually save that machine, the program of that machine, on our laptop, and this is normal the way that we do things when we do changes. Because you don't want to destroy the original program in case something is wrong with the new modified program. So what you will do is you will go to the PLC while a machine is running. You will then do a backup copy of that program. On another program, you will do your changes and you will actually modify the program as needed. And when there is time available, when a machine is down, for example, you will reload your program that is simulated and tested, and you can then verify the operation of the machine. In case if there's any unforeseeable incidents or items, You can wipe out your new program very easily by restoring the backup program and reload the original program without affecting production. Now, this cannot be done with relay logics. Today, more than one programmer is available that can program the PLC software, especially when it comes to extremely complex machines. Now, we're not going to go into the detail of this, but normally we do an agreed input and output list, an agreed input and output list of the internal bits and counters, etc. We have agreed objectives, what each program must be able to fulfill the requirements. The targets is clearly defined, and the deliverables of the project is clearly defined. And then each person can go his own separate way and even at his own home design that one specific part of the components. And another person can assemble all of these different programmers, the software written by the different programmers, into one huge control system. Now guys, at the end of the day, PLC supports least cost. It supports the maximum safety and best operational practices. And this cannot be met with any other conventional hardwired control systems. In the competitive world, cutthroat business of today, fault finding and effective maintenance and operation is a must-have to survive in the industry. And if you are an artisan and you do not have this PLC knowledge and background skills, you will find that it's very difficult to actually accelerate your own skill, and you will actually always be lacking behind. Because today in most factories you will find the PLC, and that will be required from you to do fault finding at the least minimum of time. And you must have the confidence when you deal with PLC equipment. And every person has the opportunity to actually learn PLCs and to become confident so that the PLC is no longer a threat to you. So you can see the advantages. I did not exhaust all of the advantages. The 17 advantages that was given in this lesson was just the most important ones. And PLC equipment will become more and more evident on factories as we proceed in the future. And please, this is an investment of your own skill. This is your life. You have to invest in your own life. Increase your skills. Learn PLCs to make your life easier. You are going to work for the next 40 years of your life in a factory probably. So you need to have the best tools to cope with PLC equipment and to be able to even write a simple programs for certain easy functions. Now to test this, we came to the end of lesson 2. Guys, please subscribe so that you can inform when videos is uploaded, and actually that you keep track with the videos as it happens. Please subscribe, guys. That I need the subscriptions in order for me to develop these PLC training sessions further. Unfortunately, now that the test period is coming in, and I'm going to give you some time to read through the questions, and then you must select the best option possible. Make sure that you've got a piece of paper with you that you can write the number and your option that you have selected. Now questions, please select the correct option. Only one option is the correct one, except where it's indicated that more than one selection is possible. The pass mark, this is for you guys. The correct selection of at least 6 questions must be done. If you only achieve 2 correct answers, please go through the training material again and make sure that you fully understand what the objectives and the target of this training session was. Now the first one, PLCs can be applied. Sorry, things is happening. The first question is, PLC can be applied to assist of energy savings. You should not battle with this one. A, yes. B, no. C, not sure. That is the options that you got. So write down on your piece of paper 1 and your selection, A, B, and C. And I will give you some time to think about it before we do the next question. Now 2, PLC systems can generate soft-start applications when significant large motors are encountered. And the possible answer to that question number 2 is A, yes, B, no, C, not sure. So think about this and make your selection. Okay, now we come to question 3. Is it possible to use an HMI? An HMI stands for Human Machine Interfacing. In other words, man-machine interfacing. Is it possible to use a man-machine interface for safer fault finding and machine operation? And you got 4 possible answers. A is yes, B is no, C, not sure, and D is only when the operator feels like it. Okay, please make your choice here and select your best option. Okay, you should be able to be past that one. Now, what is meant when SFC programming tools are discussed? Now, select the best fit as one option only. What is SFC? What does it represent? Does it represent A, ladder programming? B, its appearance is that of a flow diagram of the machine? C, it's a C++ programming only technique and you need to be skilled? D, it's a special function block? And E, none of the above. So when we talk about SFC, what does it represent to you? What value does this tool actually give you? A, B, C, D, or E, and I'll give you some time to think about it. Okay, by now we should have that answer. 5, the most common programming language or tool in use today for the end user. I just want to change this. The end user is the person using the program, but in our case, we are referring to the programmer itself and what benefit the programmer is experiencing. So the question is, which is the most common programming tool that we use to program PLCs? And we got ladder, B, statement listing, C, General Electric, D, C++, and E, flow diagrams. Now, what is the most common programming tool that we use? I'll give you some time to think about it. Write down on your piece of paper for question 5, which is your option A, B, C, D, or E. Okay, by now you should have the right answer. Now, this Question 6, a PLC can be used to communicate with a different machine. That's the question. The question is asked, can a PLC be used to communicate with a different machine? A, the possible answer is A, yes, if the machine is fitted with the same PLC. B, no, it cannot be done. C, yes, with communication protocols, different PLCs. Different PLCs can be used. And D, yes, if the other machine is fitted with relay logics. And E, only when they are close to each other. So can a PLC communicate to a different machine? Yes, if the machine is fitted with the same PLC. B, no, it cannot be done. C, yes, with communication protocols, different PLCs can be used to communicate to each other. Or D, yes, if the other machine is fitted with relay logics. E, only when they're close to each other. I'll give you some time to think about it and to read the questions and the possible answers again. Okay, by now you should have the answer. The last question is, what is a function block? What does a function block represent to you? And here we have to select the best two options. Now A, it's a temperature block for a PID. B, it's a programming tool. And C, it consists of a code that can be reused in future programs. And D, this was not discussed in this lesson. And E, it's a special code for the use of the human-man interface only. I think the question is clear, and I'll give you some time to read through the question again and to read the possible answers and to come up with the best option. Okay guys, by now we should have the answer for this one. Let's just discuss the answers to the questions very quickly. The first one is saying that a PLC can be applied to assist with energy saving. The answer is yes. Can be done. Now PLC systems is the question. PLC systems can generate soft-start applications when significant large motors are encountered. In this case, it's again yes. And it also, the third question was, is it possible to use an HMI for safer fault-finding machine operation? The answer is yes, it's true. Then the fourth question was dealing what is meant when we talk about SFC programming tools. And you had to select the best option that describes SFC. It's not ladder programming. Its appearance is that of a flow diagram of the machine. And that gives you the best option. Sorry, that should not have been done. Its appearance is that of a flow diagram of the machine. Is the best option. It's not a special function block. It's none of the above. An SFC will tell you and will present to you an equivalent of the machine flow diagram, and you can then follow the various functions of these machines that you are busy modifying or doing fault finding. Now, the most common programming tool that we use today that is available to the programmer, and this applies to all PLCs right through the world, is ladder. Everybody, every PLC programmer, no matter how advanced he becomes on PLCs, we'll start using the ladder. Ladder, for example, Modicon 84 was the tool that was used to program PLCs. Now the next question is a naughty one. I think a lot of people battled with this one because there's actually two answers that both is acceptable. The PLC can be used to communicate with a different machine. And actually the answer, yes, if the machine is fitted with the same PLC, we've got the same problem again. Yes, if the machine is fitted with the same PLC, it's true. And also, that one is true. Sorry guys. I'm in a hurry today, so things is happening. Both are correct. I tried to make you think a little bit. It's no good for me to just tell you about PLCs. I want you to think a little bit more clearer as well. Yes, if the machine is fitted with the same PLC, we can communicate to him. But also, yes, with communication protocols, different PLCs can communicate to each other. Okay? Sorry for that trick, but I'm trying to force you to think. Now, what is a function block? Select the best option. Then the option was a temperature block for PID. That is not relevant. It is a programming tool. It's true. Does it consist of a code that can be reused in future programs? And that's also true. It was discussed in this lesson, and a special code for the use, it's not true. So a function block is a programming tool that we use to simplify future developments, because it is actually a code like it's 6 that we can reuse in the future programs. Guys, I hope you learned something. I hope this is worth it. Please stay with me and let us do this path to your own success, step by step, day by day, video by video. And at the end, you will have a better comprehension of PLC programs. My viewpoint is easy. I don't want to talk too much. I want to do the doing and practical applications, and to force you to actually understand better PLCs. And please, my experience as a certified engineer is coming from the days of Modicon 184 right up to the most advanced systems that you can think of, and even much more, the systems like SCADA control. But at the moment, we're not focusing on SCADA control, we're focusing on certain aspects on a day-to-day basis, step by step. And I hope I can change your mindset that PLCs is not that impossible to do. It is in your capability, and you can do it. And I hope you enjoyed this video. Please comment and please subscribe. Thanks a lot, guys.